In this question we have to find the number of subsequences where the sum of the smallest and greatest element in that subsequence is less than equal to the target. Okay, so I will explain now one first solution. So first solution, what I am doing is, look here in this function. So first I will sorting is done so that we can apply the upper bound functions. Okay, so I will start moving from I is equal to 0 from the first element, and then I will check that whether if we take 2 times that element, like if we take that single element, then will will, uh, will that satisfy our condition, because we can see that only 3 is also taken there. So this 3 is taken one time. However, since only one element is there, so smallest element and greatest element will be same, so the sum is equaling as 6. So 6 is less than 9, that's why this will be one of the valid answer. Okay, so we will check if this value satisfies or not, and then what we will do, we will try to find an element, this element target minus value, in the range I plus 1 till the end of the element. You can see this nums dot begin plus I. Okay, so plus I is at the ith location, and when we do plus 1, that means that we are ahead of the ith position, just one position ahead of the ith position. So what we are doing, we are trying to find target minus value in the range I plus 1 till the end of the array. So nums dot begin plus I plus 1 and nums dot end, and then since this is the upper bound, it will give an element which is greater than the element what we are looking for. Okay, and nums dot begin plus I minus 1. So what happens here, suppose, okay, see, so if this is the ith position, then we start looking from here, right, till here, till the end of the array here. And suppose if this is our upper bound position, then when we subtract this position, then we effectively get this count of elements, right? So if we do here plus 1, then only we will get this number of elements from here. Okay, from here till here. So 1 2 3 4 5 6 elements we will get if we will do upper bound minus I so this is I plus 1 position, right? So this is I plus 1 position, and this is upper bound. So if we do upper bound minus this position plus 1, then we will get this number of elements. But if we will do upper bound minus this, then only we will get this number of elements. Okay, either this, either from here to here, or we can say from here to here. Okay, so what we are effectively doing, that we are finding those number of elements, and then we are taking all possible subsets of those elements. However, we are subtracting the empty sequence from here, right? Why we are doing that empty sequence? Because we need to fix this element, because this element has to be considered. This will be our smallest element, and whatever sequence of elements we are taking from here, among those elements, whichever will be the biggest element, that will be combined with this element, ith element, and then it will only satisfy the condition. Okay, so we are avoiding the empty subset, because for the ith position we are already considering, right? If we have 3 5 6 7, and suppose we get from we have I is equal to 3. Okay, and our upper bound comes here at j, so we will take only 3 elements. only this 5 and 6, right? Only 5 and 6 we will take as number of elements, and we will get three proper subsets here. Okay, these proper subsets will be 5, 5 comma 6 and 6. Now when this ith position 3 will be combined with them, so it will be like this. Okay, so here also sum is less than 9 or equal to 9, here also sum is less than equal to 9, and here also sum is less than equal to 9. So what we are effectively doing, we are fixing the position of this, and we are considering all the subsets here, only the proper subsets. And when this 3 will be combined with the proper subsets of these elements, so our this condition will be satisfied, that sum should be smaller than or equal to the target, right? Why we are not taking the empty sequence? If we will take empty sequence, then 3 will be combined with this, and we will count this, right? 3. But in the event of counting this 3, we are double counting, because we have already considered this part, value times 2. Now we can also argue that why don't we remove this thing, right? We remove this thing, and we count the empty sequence also here. But when we do that, suppose if at ith position we get 5, so 5 will be combined with this empty sequence, and 5 will be combined with the empty sequence, and this will result in the subset of 5. And now 5 is also the smallest, and 5 is also the greatest element in this subset. So summing it, we will get 10, and 10 is greater than our target 9. Suppose if we take the target 9, then 10 will be greater than 9, so it won't satisfy. That's why, to avoid such a condition from occurring, we are already deciding for the ith number, right? We are deciding for the ith number here, and then we are deciding for the I plus 1 position elements, like whatever elements we can get from the starting from the I plus 1th position, that we are dealing here on 31st line. Okay, and now we will count all those proper subsets excluding the empty subset, right? So this is the first solution. Okay, now dealing with the second solution, low. So this is 2-pointer solution. We have low at 0 and high at at length minus 1 position. Okay, so what we are doing, we are summing those elements. If that sum is greater than the target, then we are strictly decreasing the higher pointer, like, okay. And when and for the case when the sum is less than or equal to the target, what we are doing, we are simply, let me explain you. Okay, so back to this diagram. So what we are doing, that we are here. Okay, this is our low, and suppose this is our high. Okay, so this is our low, this is our high. So what we are doing it, like in this solution, we can say that we can see that we are doing high minus low, right? So if this is our high and this is our low, so when we do high minus low, we effectively get elements from here till here only, right? We get from elements till here only. So this and this only, not here, because if we need to include this also, then we will be doing high minus low plus 1. That's what I was explaining here in the beginning, right? So we are only doing high minus low. Okay, so when we do this thing, and we take all the subsets here, right? We are not we are not excluding the empty subset here. Why we are not excluding the empty subset? Because this thing, this element, like when we are taking high minus low, so effectively it is either taking it is taking this number of elements, but in actuality it will take here elements, right, from here till high. Okay, so all these elements it will take, and one empty sequence will be there, one empty subsequence will be there. So this element, lowth position element, will combine with all the sequences, right, and then we are doing, like, we are following this pattern only. Now the third solution what I will explain is, we are back to that position, that at that position, at ith position, we are taking that, can we take it two times? If yes, then we will add plus 1 to our solution, and then we will do high minus low, and we will exclude the empty subset here. Okay, so this is a better solution from my point of view, this better solution, and this was the better solution. Okay, thank you.